Hey guys, welcome back. So we said on our last video we had to we got our spindle motor installed, but we needed some bracing. So here's our first brace, just a little triangle, and that's gonna stiffen it up. We're gonna basically tie the two plates together we built. Oh, here she is. Just got done welding. We're letting it air cool right now by these fans. Here she is. I think that's gonna do it. If we have to add more, we will, but I bet you this is all we'll need. Alright guys, this is going to be our first test cut. I haven't done anything off camera. I don't know what's about to happen. So, we've got a 5/8 indexable end mill with 2 flutes. And we're going to remove 0.3 cubic inches a minute. And we got this set where we're going down 0.42 inches. We're going to step over a 33 thou. We're going to feed it at 22 inches a minute. And we got our spindle at 2,500 RPMs with our new motor. We don't have air blast on, but let's just try this real quick. Let's see if it's horrible or amazing, or see what happens. Also, because the side of this is round, it won't be a full width of cut. It's only going to cut at the bottom. But let's just see what happens. That's not bad, but it's only cutting at the bottom. Well, damn, how about that? This guy just shut off. See if he'll come back to life. That sucks. Yeah, the whole thing just powered off. I don't know if he killed it or what. It's nice having a tack while it lasted. Alright, so we've got our feed up 20%. We're going to go up on 20% RPMs and do a cut and see what happens. RPMs should be around 3,100 now. Like I said, our feed's up 20%. Let's see what she does. Yeah, if anything, that sounded better. Okay, so this is 40% more RPM and 40% higher feed. So we maintain the same chip per feed. So, RPM. Okay, this is 60% override, so we're feeding 880 millimeters, and we're feeding RPMs at 4,160. There she is. Well, that's the best one we've done yet. Shut this off and show you that. Let me bring it back. No, I want to show you what this looks like. Hold on. Turn the spindle off. Let that quit spinning. There's a burr that we haven't cut off yet, but here's our surface finish. Not that bad. That's pretty smooth. I mean, this is roughing, so, you know, you're not going for surface finish, you're just trying to cheaply remove metal quick. Look at the chips. Here's our chips. So you see some of these are, let's see, there's some, I don't know, that's what they look like. pretty decent sized chips. There's our end mill. Ooh, that's hot. This carb bed was kind of dull from previous use. I didn't change it because I really didn't want to change too many things at once. This thing definitely liked RPM there. That's it was less chatter, it was quieter, and we definitely got a better surface finish that time than we have before. Which is not surprising. They say you're supposed to run these things fast. Okay, so we're doing 80% higher than our base. So instead of 550 millimeters, which is 22 inches, we're going up to basically 1,000 millimeters. So it's almost double. We'll be feeding roughly 40 inches a minute. And our RPMs are also going to go up by 80%. I'm going to do that real quick and see what the RPMs that gives us. I think this is about 4,700 RPMs. 44 inches a minute, 4,700 RPMs. Yep, that looks amazing. That's, man, for roughing, that's pretty awesome. Also some dull carbide. Kind of dull. Yep, that's still hot. Wonder how many times I'm going to do that on camera. How about it? Man, I wonder what the math is. I got to go do it real quick. See how much what our material removal rate is. Alright guys, well we just did the math on our calculator, running the 80% higher feed and 80% RPM, and also correcting for the, we thought we were going to do 0.42 inches, but we ended up doing 0.38 because that was too aggressive. But after correcting all that and running it through, these chips are coming off at 0.5 cubic inches a minute. So half a cubic inch a minute of material removal rate. And that is awesome considering this is just a little PM25 with a motor of the large ass variety, but you know, you see the motor's like as big as the machine kind of. But and you know, it keeps getting better as we were speeding up. We only went up to like 4,700. This will go to 6,000. And I'm guessing that as I go faster and faster, it's just going to get better, because that seems to be what's happening. The surface, the machine, you know, this is how it's always been. More RPM, it chatters less, and you get better surface finishes. And then the tools usually last longer too, at least as far as how much metal they remove before they die. And so this is good. But here's the thing, we are overheating. I've got a piece of tape. This is the spindle, and I got a piece of tape on it, and that's so I can hit it with a infrared thermometer. So when you're using one of those, I'll actually tell you a little bit on here. They have like a little cone, so the further you go away, as you get the piece farther and further away, it's kind of doing an average of an area. So what I do is I get the sucker right up in here like that, right up on it, and then pull the trigger. You take a reading, and you want to do it black. So black has a thermal emissivity of 1, which basically means it absorbs all black body. It's like it absorbs all radiation and rejects it as well. So this thing will read accurately on a black surface. If you shine this on a shiny surface, actually I can show you. So we'll hit this black one. You'll see 133, basically, 132.9. Come over here to the shiny one. It's the same temperature. It's only reporting 112. Now that's not accurate. If you can just touch it and feel it. But usually when this thing gets up pretty hot, it might show 160, and over here it'll show like 120, and then you touch it and it burns you. So anyway, this sucker is getting hot. We got up to a little over 160 doing those test cuts just there. So we know we gotta work on that. Tell you what, one cool thing, this spindle, nothing, but I mean it's got water cooling. So that's the great thing about this. That's water cooled, so we don't have to worry about it. But this is going to be a problem. So this is going to be the next thing. I'm trying to decide if I'm about to tear into this. I guess I am. I just don't want to. I got to pull all this apart, which is kind of a pain, and then adjust the preload and put it all back together. And this could be an iterative process trying to get it right. But essentially, we have a little too much preload. And it's causing too much friction, and then it's getting too hot, which was okay at low RPMs, but it's not okay at higher RPMs. If we keep running it this way, we're going to overheat those bearings and cause damage. So unfortunately, even though it's working great there, this temperature problem has to be addressed or we'll end up having a bearing failure. So the next step, we gotta take all this apart and play with the bearing preload until we get that happy. But yeah, it looks like the actual motor upgrade itself is doing what we hoped. Our tachometer died, which sucks. Maybe if I unplug it and plug it back in, it'll come back on. I don't know. It looks sad to me. Go figure, you know. But I bet I can just buy a tack and stick one on here or something. But anyway, it is working better. Our braces fixed this. It's not flexing anymore, or it's not flexing enough to matter. Our belt stayed tight. We didn't notice any belt slippage. I don't see any rubber up here. Belt looks to be fine. So we do have some vibration coming from this. Like we said, so far this is working well, so I do think we're gonna pay somebody to make us a custom part that'll fix that. But this is doing what we intended. We bumped our RPMs up, we bumped our feeds up, we're getting better surface finishes. We should see longer tool life, and the machine's quieter. So basically everything's working as expected, and the only issue we were really anticipating was that these bearings would overheat, and they are. So now we'll address that. Alright guys, that's going to be it for today. We're going to knock off early. It's like 6 o'clock. So as you can see, we got the spindle back apart. So inside of here, that's the race for the upper bearing. And down there, there's another one in this area for the lower bearing. Well, I took it apart. Bearings look fine, which I mean I replaced them and I haven't hurt them. They look okay, they look great. But this thing was getting too hot. And I tried adjusting the preload and taking the preload off, and didn't seem to, I mean, loosening the preload helped a little, but after that, it never got better. It basically just stayed the same. And so what we're thinking is, it's all the grease. There's just, I probably packed these between 30 to 40% grease. And I saw some had slung out, so I may have just had too much grease or something. But what I think we're going to do is we're actually going to convert this to running oil instead of grease. So basically, instead of having a roller bearing that's packed with, you know, 50% air, 50% grease, these things will be running in a light mist of oil, which it's going to take some work, but I don't think it's actually going to be that bad. So if you look in here, here's your bearing, which is roughly where my finger is, and the other bearing is down here. So basically somewhere in the middle, we're going to drill a hole, and what we'll do is we'll drill a hole in the side of this, so when you install the spindle, when this spindle goes back up here in the headstock, we're going to drill a hole through this, and it's going to intersect a hole in here. And we'll basically tap this and put a fitting, and then we'll, y'all have probably seen those little misters. They actually have a hose that looks like this, but you can use them for minimum quantity lubrication, where it basically uses an air blast and it picks up a little bit of coolant or oil or whatever you want to spray. We're going to buy one of those and set it up on probably set it up on a timer where it all happens automatic. But basically say every 10 minutes it'll kick on for a couple seconds, blast some air through here with oil mixed in, and the great thing is by injecting it in the middle, it'll pressurize in the middle, which will force air and oil up into the upper bearing and force it down into the lower. One of the problems people have is people that go with oil systems, typically they do a drip, and it drips in here, and what happens is when you're running the machine, the oil drips into the top bearing and it spins around, and you know, the upper bearing's happy, but that oil kind of hangs and it doesn't drip and fall down and catch the lower bearing. So what happens is you end up having the upper bearing over oiled, the lower bearing can't get oil. Or for example, you have to oil the piss out of the upper one so that some of that oil will fall down and catch the lower. So I think the air mist setup will be better because it'll be able to force the oil in every direction. And I'm going to research this tonight, but a quick Google search shows that that's a pretty common way to oil stuff, and it's very reliable. So that's cool. I think that's what we're going to do. So that's going to be it for now, and yeah, it's a project, but I think this thing's winding down. This motor, I took some measurements here. I'm going to model up a part or a pulley or something. Maybe I should have brought that pulley, I don't know. But we're gonna work on that too, because I want to get a custom piece here made, and we'll get these bearings going, and hopefully that's about it. This machine will be fairly capable at that point. Alright, y'all take it easy.